Imagine we're stepping into a cosmic detective story, one that's just packed with moving shadows, unseen forces, and absolutely breathtaking stellar anomalies. Welcome to this explainer. Today, we're looking at a space phenomenon that has literally puzzled astronomers for over a century. And the clues we're going to uncover together might just challenge our fundamental understanding of how the universe is actually structured. So, our mystery kicks off at a staggering distance of 2,500 light-years away from Earth. Just to kind of wrap our heads around that perspective, the light we're observing from this cosmic structure today, it actually began its journey toward us right around the time of the ancient Greek philosophers. Just wild to think about. Specifically, we're focusing our lens on a very particular sector of the night sky, the Monocerotis constellation. Tucked right away in there is our celestial crime scene. It's officially cataloged as Caldwell 46, but you'll usually hear it called by its much more descriptive name, Hubble's Variable Nebula. Now, despite the name, it was actually discovered by William Herschel way back in 1783. But this nebula's bizarre, constantly shifting nature was famously studied and confirmed by a young Edwin Hubble in 1916. You can actually see Hubble's very own 1916 notes and sketch right here. He, along with his contemporaries, noticed that the shape and brightness of this nebula seemed to change rapidly, sometimes within just a matter of days or weeks, which, let's be honest, is an absolute blink of an eye in cosmic terms. The source material reveals that what Hubble and the others were observing wasn't just some static cloud of expanding gas. Nope, it's a reflection nebula. Deep inside, there's a hidden, highly active young star called R Monocerotis. This star is constantly casting light against the surrounding dust, but there's rotating material near the star casting these mysterious, fast-moving shadows across the wider gas cloud. It acts almost exactly like a flickering cosmic movie projector, just throwing ripples of light and dark across this massive celestial screen. Modern technology, though, completely changes the game here. While the left side gives us optical observations, the right side shows how infrared and adaptive optics allow us to literally peer right through that dense space dust obscuring the visible light. This completely transforms our view. We go from looking at surface-level flickering shadows to seeing these profound underlying structural anomalies that older optical telescopes simply had no way of seeing. And when astrophysicists looked closer at the eastern edge of the nebula using these advanced techniques, well, they found a jaw-dropping clue. They didn't just find random clumps of gas. They observed this massive, incredibly complex twisted double helix of filaments stretching deep into space. The researchers noted that these filaments resemble a twisted magnetic field, which, raises an entirely new set of questions about what is actually holding this whole structure together. Take a look at this 3D mathematical model, which was derived directly from the observational data. It reveals this incredible DNA-like spiral wrapping right around the edge of the nebula. And to really grasp the sheer scale of this spiral runs from 1,000 to 100,000 astronomical units away from the central star. Since 1 astronomical unit is the distance from the Earth to the Sun, we are talking about a twisted structure of truly unimaginable proportions. All of this brings us to the most pivotal question of our explainer. Think about it. Gravity alone generally tends to pull things into spheres or flat disks, right? And explosions, well, they tend to push things outward in expanding bubbles. So, what unseen cosmic hand could possibly sculpt such a precise, twisted, rope-like shape out of raw space plasma and over such vast distances? To solve this, the source material points out that we really need to look at forces that are often completely sidelined in traditional astronomy. We're talking about the powerful, intricate interplay of electricity and magnetism. While astrophysics has traditionally leaned heavily on gravity to explain cosmic structures, our sources argue that electromagnetic forces might just be the missing piece of this puzzle. To understand how these forces actually shape space, we have to talk about something called Birkeland currents. In really simple terms, space isn't just empty, it's filled with plasma, which is highly conductive. Birkeland currents happen when electric currents in space naturally align with and flow along magnetic field lines. When charged particles flow like this, they actually generate their own magnetic fields, creating this highly organized, self-sustaining structure. The mechanics of this are mapped out in a force-free, field-aligned model presented by researcher Donald E. Scott. According to his model, when plasma organizes itself into these currents, the electric current density and the magnetic field point in the exact same direction, what physicists call becoming collinear.
Because they align so perfectly, the system reaches the lowest possible state of magnetic energy. It effectively eliminates internal resistance and those crushing pressures known as Lorentz forces. The result? It creates these incredibly stable, long-lasting cosmic structures that can maintain their shape over massive interstellar distances.
Inside one of these currents, as you can see in this cross-section, the magnetic field and electric current don't just travel in a straight line. They inherently wrap around the central axis. As you move outward from the center, the pitch of that twist changes, which creates an uninterrupted spiraling helical structure. It's not magic, it's just a natural consequence of the physics of electromagnetism interacting with plasma. And what's crazy is that the structure is incredibly mathematically precise. Looking at this graph from the source material, you see the magnetic field strength isn't just uniform. Both the magnetic forces running along the axis and the ones wrapping around it cyclically reverse their directions and decrease as you move outward from the center. The total magnetic field magnitude essentially acts as a precise scaffolding. It's this exact mechanism pulling the nebula's matter, the gas and the dust, into those distinct twisted bands we saw earlier on the eastern edge of Caldwell 46.
So the crucial takeaway here is that this represents a fundamentally different way of viewing space phenomena. Traditional astronomical models rely a lot on concepts like magnetic reconnection to explain changing fields and energies. But the sources note that magnetic reconnection really struggles to explain what initially moves those fields or holds them together. An electrical model, on the other hand, relies on the actual, observable electric currents that generate, move, and shape the magnetic fields in the very first place. It provides a direct physical cause.
Bringing it all back to our prime suspect, Caldwell 46, we can really see these forces in action. By mapping the polarization of the light, which is traced by the vectors overlaid here, astronomers can see exactly how the dust is aligned. The model suggests that rotating dust streamers are being entrained and guided by these exact magnetic and electrical forces. As they rise up along the twisting magnetic field lines, they periodically block the light from that central star. Boom. Those are the moving parts casting those famous, fast-moving shadows that Edwin Hubble observed all those years ago.
And it turns out Caldwell 46 is not an isolated case. Just take a look at the Hourglass Nebula, which is another stunning cosmic example highlighted in the research. Here, you can visibly see these concentric cylinders of plasma. The physics of electric currents describe a phenomenon called a Z-pinch, where the magnetic fields generated by the current literally squeeze or pinch the plasma into these highly distinct glowing cylindrical tubes. I mean, the geometry of electricity is just written all over it. We're looking at a potential massive paradigm shift in astrophysics here. As the source material from Donald E. Scott argues, continuing to ignore the role of electric currents might severely limit our understanding of how the universe actually operates. By bringing electricity and magnetism back into the picture alongside gravity, all these previously enigmatic shapes and motions in space suddenly have a clear, testable, and physical explanation. Which leaves us with this final, thrilling thought to wrap up our explainer. We've just seen how these forces can explain the moving shadows and that massive double helix of Caldwell 46. But if invisible electrical currents are the unseen hands shaping this distant nebula, what other impossible shapes are they sculpting right now, out in the deepest, darkest corners of the cosmos? It completely changes how you look up at the night sky, doesn't it?